That is a fantastic question. Ask it again. What does GCF mean? Oh, you guys have heard of it before. I think maybe you talked about it when you learned how to simplify fractions. You may have learned, well, we could reduce this fraction by saying, well, 2 will divide evenly into 20 and into 30. So that would be 2 into 20 is 10, and 2 into 30 would be 15. And then, doesn't 5 divide it evenly into 10 and 15? So 5 goes in here twice, 5 goes into 15 3 times. But if you use the greatest common factor, you could do it in one step, couldn't you? What is the greatest common factor? 10. Okay. So 10 is the greatest common factor. 10 goes into 20 twice, and 10 goes into 30 3 times. So let's think of the factors of 20 for a minute, okay? So we know 1 times 20, don't we? Okay. What other factors does 20 have?
10.
Okay, 10.
And 2.
Okay, 10 and 2.
5 and 5.
5 and 4. Anything else? Probably not, because I didn't leave any room, did I? Probably that's probably it. Let's take a look at the factors of 30. 1 times 30, I guess, right?
2 times 15.
Okay, 2 times 15. 3 times 10. Ooh, I don't think I left enough room for this middle one. 5 and 6. Yeah, I didn't leave enough room for that one. So there's quite a number of factors, but you can see 10 is the greatest common factor, isn't it? Okay. So finding the greatest common factor is what we're going to be looking at today. We're just going to be looking at some numbers and saying, what is the greatest common factor? We're not going to give you any really large ones. Like if I gave you some numbers like 550 and 415 and ask you for the greatest common factor, that might be kind of difficult, right? Okay. You can do it though by doing that product of prime numbers thing. Let's start with a couple of smaller numbers. Remember these two? Okay, product of prime numbers. What prime goes into 20?
5.
5? Okay.
2.
Wait a minute. There. 2 and
2.
okay, so we've got 2 times 2 times 5. 30. Can I do 2? And then 3? So it's 2 times 3 times 5. Do you remember the greatest common factor? We just did it.
10.
It's 10? Okay. So what I want you to notice is I want you to look here and see what they have in common. Okay? They both have 1, 2, at least 1, 2, don't they? And they both have at least 1, 5. So that's what they have in common, is a 2 and a 5. And what's 2 times 5?
10.
It's 10. Okay. Well, you can use that idea to find the greatest common factor even when the numbers are large. So we could do a couple like this. And we could do greatest common factor. Let's do the product of prime numbers. What goes into 550? 5? Okay, good choice. Good choice. 11, like that?
10.
10? Oh, can't use a 10, can we?
11.
11 again?
5.
Oh yeah, 11. Goes in there 10 times. And 5 goes in there 2 times. Okay, let's do this one. I'm guessing 5.
Again. Oh wait, is that 83?
I think it's 83. 83. And anything, is 83 prime?
I'll see, yeah.
I chose a bad number. It is prime. So what do they have in common? A 5. So what would be the greatest common factor then of 550 and 415? 5. That would be it. That is the greatest common factor. Okay. Now if we looked at, let's look at some that have a little bit more here. Let's do 300 and, well, should we do 120? Okay. What goes into 300? 3. Good choice. 5. 2. 2 again. Okay, let's do the 120.
5. 20.
Oh.
3.
Okay, 3. 3 goes into 12 4 times, right? So 40. 2. 5.
4, 2.
2. Okay. So now we start looking at what they have in common. Well, this one has 2 2s. This one has 1, 2, 3 2s. What do they have in common, though? At least 2 2s. Okay. 3s. Did it? 1 3. 1 3. So they have 1 3 in common. 5s. This one has 2 5s. This one only has 1. What do they have in common? Just the 1 5. And there it is. That is the greatest common factor. It's 4 times 3, that's 12.
60.
Times 5 is 60. Good job. Okay. That is the greatest common factor of 300 and 120. What do you think? What do they have in common? What factors they have in common? Multiply them together. Okay? Now, that's the hard bit.
That's the hard part.
Let me show you the easy part. So, we're not going to just be looking at numbers that we know, like these two. What's the greatest common factor of 8 and 12?
Probably 4.
Probably 4 or 4? Okay, 4. We are also going to have some numbers we don't know. So we're going to have a couple of terms, and we have to find the greatest common factor. This might be written as an expression this way. So it's not just 4, there's some variable part here. Okay? This is the easy part. Okay? This is the easy part. All you have to do is look at the variables and well, let's think about this for a minute. What's the greatest common factor? Greatest common factor of 3 and 9?
3.
3. Okay. So it's 3. What if I wrote this one as 3 and I wrote this one as 3 squared? Would that matter?
No.
What would the greatest common factor be still? Still be 3, wouldn't it? What if I had a 27 over here, 3 to the 3rd power? What would the greatest common factor of all of them be?
3.
It would just be 3, wouldn't it? Okay? Do you notice what we're doing? We're taking the lowest exponent, aren't we? So if I had, what's the greatest common factor of, say, 25, which is 5 squared, and 125, which is 5 to the 3rd power, what's the greatest common factor? 5 squared. What's the lowest exponent? 2, right? Won't 25 divide evenly into 125? Yeah? So there's your greatest common factor, 5 squared. So let's take a look up here. I'm going to start with the m's. M squared and m to the 4th. What's the one with the lowest exponent? M squared. P to the 1st and p to the 2nd. P to the 1st. How about z to the 4th and z to the 3rd? Z to the 3rd. That's the greatest common factor. That's all there is to it. Look at the variables, take the variable with the lowest exponent. I told you that bit was easier than the number part. Let's see. Okay, so we're going to talk about the greatest common factor. Let's start with the number part first. 16, 4, and 2. What happened? You all just quit on me. Come on, greatest common factor of 16, 4, and 2. 4? 2. Why not 4? Why not 4? Okay, because 4 is not a factor of 2, is it? Okay? 2 only has 2 factors, 1 and 2, so it's got to be one of those. Okay, let's do the variable bit now. And these are all in the order x, y, p, so that's the way I'll do it. X to the second. Y to the first. P to the first. There you go. Lowest exponent. What if I had a z on that one? And I had a z to the fourth on this one. Let me just ask you this. Is z common to all of them?
No.
So can it be part of the greatest common factor? No, if it's not common, it can't be part of the greatest common factor. So it would not be part of our answer down here. So this would still be the answer. Now, if you had a z in this one also, now is it common?
Yes.
What's the lowest exponent? Z to the first. It would be in. Okay? But it's got to be in every term. It has to be common in order to be part of the greatest common factor. Here, I'll write down an expression, and you guys write down the greatest common factor. You don't have to write down this original expression that I'm writing. Make sure that you put GCF equals, like that. Are you going to be happy when these show up on the assignment? No, Ryan? They're not super easy and fast to do?
Oh, I don't think I can try to shake my head.
Yeah, I love it if these show up on my assignment because what's the greatest common factor of 5, 60, and 30? 5. Okay, now with the A, make sure it's in all the terms. Make sure it's common, and then take the lowest exponent. Same with the B. Is it common? Okay, take the one with the lowest exponent. C, is it common? Okay, take the one with the lowest. That's the greatest common factor. Who did that correctly? Dang, you guys are either you're good or your teacher is awesome. I'm not. Maybe both. Could be both. Okay, so that's going to be easy. When you run into those problems, you're not going to have any problem with that at all. So 20 and 21 are going to fly right past.
Only 2 questions?
Yeah, only 2 like that today. The rest of them are review. Tomorrow we will have a test that will cover only up to set 28.
Wait, if we have a test tomorrow, we can't do assignments today because our brain's got to rest until
Yeah.
tomorrow.
Yeah.
That makes sense.
Yeah, no. Okay, set 34.
You thought about
Let's
it.
get it done.
Alright, how about we only have to do one?
Actually, it just made my brain hurt thinking about it for a second, and then I had to recover.